Hello everyone and welcome to Solving Solo series for CAT examinations. Solving one question at one time. Pause the video and try to solve it. I hope you have the answer by now. Let's solve it with concepts. Consider a triangle drawn on xy plane with its three vertices at 41, 0, 0, 41 and 0, 0. So this is our triangle. Let's call it ABC. Each vertex being represented by its xy coordinates. The number of points with integer coordinates inside the triangle, excluding all the points on the boundary, is. Now, very easily we can solve this using Pick's theorem. If we have a polygon or a bounded figure, then there would be integer points on the boundaries and there would be integer point inside the bounded figure. Then according to Pick's theorem, area of the bounded figure is given by b by 2 plus I minus 1. B means boundary points, I means integral points inside the particular bounded figure, and 1 is 1. So we would be using the same formula to find the value of I. Now, first we need area. Area of triangle ABC is half into base length into height length. That is 41 units into 41 units by 2. That would be 840.5. Fine. Now we need boundary points. On boundaries we can see that we have got three straight lines. Line AB. On line AB the points are moving from 0, 0, 0, 1 to 0, 41. That means there are 42 points. On line BC, these points are moving from 0, 0 to 1, 0 to 2, 0. Minded, we are considering only the integral points. Integral points means both x and y should be integers. 2, 0 till 41, 0. That means here we will have 42 points. Now on line AC. Line AC, first we need the equation. Equation would be x by 41 plus y by 41 is 1. Okay, let's start with the first point. First point on this is, if we start from point A, it is 0, 41. And then since the coefficient of x and y both are same, that is 1, next point would be 140, then 239 till 41 zeros. All these are integral points which lie on the line AC. So we have from 0, 1, 2, 3 till 41. So here also we have 42 integral points. So number of boundary points are 42 plus 42 plus 42, but we need to deduct this point A, point B and point C, which is being considered twice, minus 3. So that will give us 123. So B value is 123. B by 2 is 123 by 2, that is 61.5. Okay, so what would be I? I, that means integral point inside this bounded figure, would be area minus b by 2 plus 1. This 840.5 minus 61.5 plus 1. That will give us 799 plus 1, that is 780. So there are 780 integral points inside this bounded figure which we are looking out for. I hope you have understood this Pick's theorem and it is very helpful in solving these kind of questions. I'll see you soon. Thank you.